Yes. Okay, let's try again. นักเรียนครับเดี๋ยวรบกวนอีกทีนึงนะเมื่อกี้เน็ตมันหลุดแน่เลยนะซึ่งว่า
now 11, 17.
แล้วเมื่อกี้ก็ว่าเด็กๆซะเยอะเลยขอโทษนะครับเมื่อกี้มาเซอร์บ่นไปเยอะมากว่าคนเข้าเรียนน้อย
24.
โอเคเมื่อกี้ได้ดูเอาแล้วครับ
Can start now?
Yes of course
Okay, good afternoon students. Don't forget to write your name, your class number, and your class. Okay, a while ago there's a problem with the connection. Okay, we'll start now. This is for our class time for M.4 IET, and we have to move forward. Okay. So this is okay. This slide is for our subtopics. We have applications of functions, types of functions, and domain and range of functions. These are the three subtopics of the lesson for today. So, what are the objectives for today's lesson? So the first one is you have to identify the applications of functions to real life situations. And the second one is identify the types of functions. And the last is find the domain and the range of the function. So these are the objectives for today's lesson. Okay, next is this. So we have here a chicken. It says it's party time, but actually it's not party time. Now we have to study. The question is, if your mom goes to the market, and buys some chicken, what kinds of food or dinners might she make? Again, if your mom goes to the market, she goes to the market and buys some chicken, what kinds of dinners might she make? Okay, can you comment down your answer? Okay, I have 3 answers. Okay, start now. Okay, by the way, I'm going to give extra points for those who always answer using the comment section, comment box. What kind of food or dinners might she make after she bought chicken from the market? Okay, tom yum kai. Thank you, Miss Hannah. Yes, who else? Okay. Fried chicken from, I can say, move forward. Fried chicken from, write your name in English, please. Number 41. Who is this number? M4/1 number 11. Okay, fried chicken. French food, what's that? Covin French food. What is it? Is it also chicken? Okay, chicken soup, yes, and many more. What is it? Fried chicken also. Thank you for your answer. So this is about function also. So if you have the money, you go to the market, what do you get? Of course, after you get the chicken, you have the food for dinners. It's like function. What do you have? You input it, and then you will get a result. So next is the video about function machine. So it is from YouTube, and I put here the source. Okay, you listen to this for the application of function, and okay, play the video. So we have here the function machine. Okay, if x is 1, y is equal to 1. If x is 7, y is 7. And x is negative 3, y is also negative 3. So this is the function of shear. Okay, so let's recall what we had last week. A function is always a R. It starts with letter R, so the answer, I'll write the answer first. So this is a relation, RELATION. A function is always a relation. Okay, number 2. Each input is related to a unique. Oh, blank, blank, blank. This is, who can answer for number 2, students? Each input is related to a unique blank. What's the word? Can you type the word? Okay, do it now. Okay, what's number 2? What is the word? Okay, correct, from room 1, number 29. Correct? And who else? Natus Flashneo, number 18, room 4. And who else? Yes, room 4, number 51, Pichayot. And many more. Camp, correct? Okay, and Pan Panovich, correct. So this is output, O-U-T-P-O-T. The third one, we do it fast. A blank blind test will tell us if the relation is a function or not. So number 3, what is it? What's the word for number 3? It begins with letter B and next letter is E. What is the word? Okay, you do it now. It begins with letter B and E. Okay, type the word. Okay, in English. Okay, don't forget to write your name in English, class in English, also your number. M4/1, 2, 3, 4, 5, 6, 7. Correct from Kamonchanog. Very good. Okay. And who else? Penny is correct. Yes. And Pichakon, correct. The word is vertical. Yes, vertical. Very good. Okay. Next we have functions and real-life applications. Example, Balatad decides to survey people so he can make a plot of his birthday function. So he asked his Facebook friends, of which he has many, to send their birthdays. Some of the data that he collected for me is in the table. So this is it. The table is here, students. This is the application. So this is, for example, name Homer. The birthday of Homer is May 1. The birthday of Grandpa is May 2, and many more. Professor McGonagall, January, and also Jones, their birthday falls on May 7. So this is the result. And when Balatad made a graph, this is the graph of the survey of the data that he collected. So this is it now. So this is, if you see, you can see that we have here, if you test using the vertical line anywhere, the vertical line touches the graph at exactly 1 point. So this graph of birthdays of people is always a function because we only have one birthday. Yes? So this is a function. This is an application of a function. Next is this. Another application in robotics. In robotics, students, function is also used. Engineers use function for building also skyscrapers. In robotics, function is used how robotic parts will work. Your robot will not work if your function is wrong. So this is one of the applications. The second is in software. We also use function in softwares. You can have this when maybe you know how to do it. When you do the electrical engineering, something like that. When you take engineering in your university, you will apply functions. Next we have functions is everywhere. So where is everywhere? This is the dish for to get satellite, and we have this one. Okay, this is also application of function, and this one is also an application of function here. So you can use calculus in making all of this, and calculus is related to functions. So functions is everywhere, anywhere. Okay. Next is this. function in engineering field. So this is what I had mentioned a while ago. For example, electrical and computer engineers use function for system design, and function is used to improve safety of vehicles. These are the applications of functions. Next is function in science. So astronomical science deeply depend on calculus and function. And this is it. In function also is used to build tracks. Okay, function in biology. Also in biology, the concentration of drugs in a living organism can be answered with function. Okay. In economics, if you want to get a higher profit with a minimum expenses, you will have to apply function. So there are a lot of applications of functions in real life. Okay? Next, we proceed to the types of functions. There are many types of functions, and we name these functions as the first one. Okay, we have this one here. The name is identity function. What is an identity function? You look at the graph. Okay, this one is the first one we have here, the mapping diagram. You see, students, we have the input and the output. With the input, we have a square. The output is also a square, so they're the same. Circle, circle, triangle, triangle, and also here. If, for example, this is x here, x is 1, y is also 1. So this is it. I'll put some points. Okay, this is it. 1, 1. This is 0, 0. This is negative 1, comma 1. And this is negative 2, comma negative 2. So what you put for x, that's also the y. So if x is 1, y is 1. If x is 5, y is 5. If the input is a square, the output is a square. So this is an identity function. You have to remember this. I'll ask you later about this if we have time, or maybe next week. Identity function. The second one type of function is this. It's constant function. What is constant? When we say constant, there's no variable. For example, 5 is a constant, and 6 is a constant. Negative 1 is also a constant. So in constant function, f of x is equal to 2, which is the same as I cannot write. Okay, y is equal to 2. So this is the constant. Because we have the equation, y is equal to 2 is a constant function. Another one here, this is the equation of the function. So this is it. Okay, y is equal to 7. This is also a constant function. So it's just a horizontal line for constant function. Okay? Do you have questions? Okay, I think there is no question. Okay, for number 3. Number 3 is this. Quadratic function. Quadratic, so meaning the form of the equation is like this. Y is equal to the quantity of something, x squared, like this. Okay, plus k is quadratic, exponent is 2. The graph of a quadratic function is a parabola facing down or facing up. So this is the third one. The fourth is this. It's curved. It's curved. So what kind of function is this? It's called cubic function. Cubic functions. It's this. So example, f of x equals x cubed. F of x, function of x is equal to y, always equal to y, is equal to x cubed. So this is an example of a cubic functions. These are the graphs, for example. Okay, the next is rational function. Okay, the root word is ratio. When we say ratio, it is in the form of a over B. Let's see it. A over B. So, for example, here 1 over x minus 2. So, this is a rational function. So, this is the graph. And we also have here negative 1 over x minus 2 equals 9. This is a rational function, and a rational function. Just remember the root word is ratio, which means the form is A over B. If you have questions, don't be shy in writing your comment or questions, okay? Students, welcome to the latecomers. Don't forget your number and your class also. Next is this, letter V. So what kind of function is this? The graph is V. It's called modulus function. In other books or in Google or in the internet, you can see this is also called an absolute value. Same, they are the same. Absolute value function. This and this are the same. So, example, y is equal to absolute value of 3x plus 2, and y is equal to absolute value of x. So, these two are examples of absolute value function or modulus function. Okay, and I think we have this. Okay. Constant function, it's the same as what we had a while ago. Yeah, it's already there. Constant function, so y of x is equal to 4, f of x is equal to 3. Okay, I already mentioned this a while ago. Next, square root function. Okay, the graph is this. Okay, the graph is this. It's like a parabola. This graph is like half of a parabola facing right. How about this one? It's like a half of a parabola facing left. Half of it, only half, because it's square root function. For example, y is equal to square root of x. Okay. Another example, y is equal to square root of x minus 2. Another, y equals negative square root of x plus 5. These are the examples of square root function. Okay? Questions? Tanabat? No? Okay, Pimu. Hi, Tua. Okay, welcome. Nakanan. Yes, welcome to our class. Next is this. So in as a summary of the types of functions, we have here identity, constant, polynomial, quadratic, cubic, rational, modulus function, and square root function. So polynomial function is just this. A linear function, the graph is a diagonal. It can be like this, or it can be like this for polynomial function. Okay? So, for speaking, everyone, students, don't be shy. I know some of you are alone studying. So, please follow this. First, our speaking activity for today before we do more. Okay, let's see.
Types of functions.
Okay, please follow types of functions. Next is
Constant function.
okay, do it. Okay, next.
Cubic function.
Do it. Next.
Identity function.
Okay, your turn.
Polynomial function.
Okay, your turn.
Modulus function.
Okay, do it.
Quadratic function.
Okay, and we have the last one here.
Rational function.
Okay. So do it one more time. Ready? Go.
Constant function. Cubic function. Identity function. Polynomial function. Modulus function.
It's not moving.
Quadratic function. Rational function.
Okay, that's it for our speaking activity for today. Next, we move on to the examples on how to find the domain and range of an ordered pair. For example, number one example is this. Number one, letter A, find the domain and the range of the following. Let's see if the relation is a function or not. So when we say relation, it's just a pairing. Very simple pairing of two elements or two components. But for function, it should be very specific. One input will give a unique output. So you cannot repeat the first component. So let's see, letter A. You have to find the domain and the range. When you say domain, remember what is a domain? Domain is the set of the first components. How about the range? The second one, the range. The range is the set of what? The second component. So let's have domain for letter A. Domain. Don't forget, it's domain. It's the set of, always set. So the first components, first, so we have here 2, 4, next is 3, next is 6, and this is 2. And 2 is already written. So do not repeat 2. Do not write again 2 students. So erase it, the comma, no, and then close. So this is now the answer for the domain of letter A. How about for the range? R-A-N-G-E. The range is always the set of the second components. So what do we have here? We have -3. Next we have 6. -1. 6 is already here, so do not write again. No. And 3 here, comma 3. Close. So this is the answer for the domain and also the range. Okay, how about letter B? So you are asked to find the domain. So the domain is the set of the first components. So we have here -3, -2, -1, 0, 1, and 2. Finish. And then how about for the range? Okay, I would like you to answer for the range. Okay, 5 students, answer what is the range of letter B. Ready, start. Okay, type your answer because we have more examples. Okay. Not yet. Number 29 of room 1, you're late. Next time come to class on time. What is that? Okay, you have the answer? That's your answer. Okay, you put your answer first. Okay, room 1, sorry, number 29. You're not late, you're giving the answer now. Correct. Room 2, number 38. Correct. Who is this? Not Pin. Your answer is wrong. If your answer is 5, it's wrong. It should be inside the set. Room 4, number 18. Wrong. Room 1, number 10. It is wrong. Something is missing. And Pon, Nachapon. Set of 5, correct. Salintip, correct. Very good. Najun, correct. Very good. Your answer, room 2, number 19, wrong. Okay, no, it's not. If your answer is 5, students, it's wrong. It should be inside the set. Open and close. You see, 5, 5, 5, 5, 5, 5. Write only 5 one time and put it inside the set. Otherwise, it's wrong. Okay, so this is the answer for domain and range. The question, is the relation a function? Is the relation a function or not? Okay, one more before we move to the next. Is the relation a function or not? Okay, letter A, function or not? Okay, who can answer? Function or not, students? 1, 2, 3, go. Function or not? Okay. Tongkok or tongkap? Room 3, number 10, not. Pongdawit, not. Room 4, number 44, not. And pond, room 7, number 13, and one more. Room 5, number 25. Oh, very good students. Excellent job. You are giving me all the correct answers. So the answer is not N-O-T because 2 is repeated. Correct, master? 2 is repeated. Because a function cannot repeat the first components. No repetition of the first components. So letter A is not a function. If it is not a function, it's just a relation. Remember, if we have this is the function, this is the function, and this is the relation. So number 1, letter A, it is just a relation. It's not a function because 2 is repeated. Okay, how about letter B? Ready? Answer. Function or not? Look at the first components only. Function or not? Okay, 5 students. Ready? Go, go. Okay. Sa linkip? Yes. Room 1, number 10, function. Okay, correct. Are you sure, Memi? Your answer is not. Not napin. Number 28 is a function. Number 11, correct. And one more. Number 13, room 7, correct. Chimpanzee, your answer is wrong. Skinny focus, correct. Room 4, number 44. Okay. So the answer is, yes, it's a function. F-U-N-C-T-I-O-N. It's a function because you see, -3, -2, -1, 0, 1, 2. No repetition of the first component. So declare B is a function. Okay, next is also domain. Same domain. Okay, find the domain and the range of the function from the graph. From the graph. Okay, how do we do this? Okay, you listen carefully. This is easy to find the answer because we already have the graph. Example number 1, you see. Okay, this is a linear function or just a polynomial function. So how do you find the domain? Okay, how do you find the domain and the range? Okay, remember, what is a domain? In this case, what is domain? Set of all x. And what is the range? The range is the set of all possible values of y. Okay. All x for domain, all y for range. So it's easy, students. You look at the graph. This is your x-axis and this is your y-axis. F of x is the same as y. Don't be confused. F of x is always equal to y. Again, this is y and this is x. So what is the domain? So you just look from left to right. Left to right. So from there, you see there's an arrow. So it's look like this. I'm going to do this. And then this. And then arrow. Left. Arrow. Right. So this is for the domain. Okay, domain. Left to right. How about for y? For the range. So you just look from here. You look. Okay. Oops. Go back. Okay, again, let me erase this. Okay, let me erase this. Anyway. For your range is from here up. Okay, so this is for range. All y, all possible values of y, all possible values of x. So what is now the domain in this case? The domain is, what is the domain in this case? So I have it in, domain is the set of all x such that x belongs to the set of real numbers. All real numbers, left to right. Possible values of x, all real numbers. Or you can write like this. Open, negative interval, comma, negative infinity, positive infinity. Either of the two is okay. Or you can write domain is just letter R for real numbers. Either of the three, 1, 2, 3 is correct. Okay, how about for the range? You look for the range. Okay, arrow down. Okay, we have this one here. Okay. Okay, we go back. For the range, we have here. Okay. The range is also set of all y such that y belongs to the set of real numbers. Or you can write range. Okay. Open interval, negative infinity, comma infinity. And then this is closed interval. Or you can also write the range as just letter R. So if you write this, it's okay. If you write like this, okay. You choose one. Okay? Next is second. Okay, example number 2. Find the domain and the range. Okay, domain is left to right. So left to right, you look. What are the possible values now of x? That's the domain. Left to right. This is domain. So what is the domain? From left to right, students. Okay, who can answer? What's the domain for this? Okay, 5. Only 5. Okay, what's the domain? Type your answer as fast as you can. What's the domain? Real numbers. Correct. Number 11 of room 1. Next. Okay, correct. Also from, yes. Room 1, number 10. Room 3, correct. Number 28 of room 3. Natlapin, salintip, also correct. And one more. Okay. Correct, students. The domain is the set of real numbers. How about for the range? The range is from what? Down, 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 up. This is for the range. Okay? So what is the range? Look. 0. So how do you write it? How do you write for the range, students? So how do you write it, master? 0. 0, comma. The lowest is 0. The highest is, we don't know. Go up, 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 up until the ceiling and so on and so forth. It extends up to the sky, to the heaven above. So what is the highest? We don't know, right? So 0, comma what? Infinity. So this is closed interval. Meaning 0 is included. It's closed. It's called closed interval. Close. and open interval. This is the answer. Another way of writing the answer is this. Set of all y such that y is what? Y is greater than or equal to 0. Okay? You have questions? Next, this is the answer. Okay. Number 3, find the domain and the range. Okay, domain. Left to right. Left to right. This extends more to the left and up. Extends more to the right and up. So it would be from left to right, set of real numbers. How about for the range? Okay, I completed. I complete the word range. Okay, the range is, you have to look, students. From here, the lowest is here. What is the value of y here? It's 0, 1. Can you see? This is, coordinate is 0, 1. So the lowest value of y is 1. So the range would be the set of all y. Set of all y, I'll change it to white. Okay, set of all y, okay, such that y is, you see, the range is here. From this up, the lowest is 1. The lowest value of y is 1. So the range is set of all y such that y is greater than, okay, I'll erase and change it to white. Greater than or equal to 0. This is the answer. Another way of writing the range. There are many, many ways. So using the interval notation, you can have this. Close 0, comma, infinity, and open interval. There are many ways. Another, maybe I'll look. Okay, another would be 0 to infinity. Another would be what? You just write this. Okay, y is in words. You can write in words. Miss, can we write in words? Yes. Y is greater than, okay, many ways to this, or equal to 0. If you are not lazy, and then you do this. Okay, I just do this and finish. Or do this, finish. Okay, it's up to you, students. Okay, next would be this. We will do this fast because we have more. Okay, this is the answer. Domain. Look at the domain. It's here already. The domain is, okay, domain. We don't really have much time. Okay, domain is this. Look, students. Left to right. Okay, open. Okay, this you look. Left to right. So, look only from left to right for the domain. What are the possible values of x? It extends more to the left. It extends more to the left. This extends more to the right, and we don't know the last. But your values of x here, you see, x here is -4, x is -3, -2, x is -1. Here, x is -0 point something. X is -0 point something. It gets closer to 0. X gets closer to 0, but it will not intersect. It will not touch. So meaning your domain is open, -infinity, comma, I'll change it to white so it's easier to look at. Okay, change to white, open, -infinity, comma. It will not touch 0. It gets closer to 0. The values of x gets closer to 0, but it will not touch. So -infinity, comma, 0. But this time, very good, master. Yay! Open, open. Yes, open. Because 0 is not included. Okay, master 5 points. Union. Union. Okay, how about the students? Look, what is the value of x here? What is the value of x? X cannot be 0. It gets closer and closer and closer and closer and closer to 0. But it will not touch. So it should be, this is okay. It should be open interval 0. Tama. What is the last value of x here? Huh? You don't know. It will extend to that building, next, 7-Eleven. We don't know. We don't know. So this is infinity and open interval. This is the answer using interval notation. Another way, okay, we do this fast because we have to study more. Domain. Set of all x such that x is what? How do you write this one? How do you write it? Set of all x such that x is what? X is what? Master? How do you write this one? Sets of all x such that x is less than 0. And this union is or x is what? More than, or greater than 0. And oops. Okay, this is another way of writing the answer for the domain. Okay, find the domain and the range. How about your range? How do you look for the range to this? You do this fast or range. Okay, how do you look for the range? Okay, from here up. From here up. Okay, so what will be the range? There is no space there. Okay, how do we write now the range? Okay, we do this fast. Okay, range is set of all y's such that. What is your y's to this? From here down up. From here down up. So it goes from here. Goes up, up. But it does not touch 0. It will not touch 0. This you see, from here go up. It will not touch 0. It will get closer but will not touch. How about here? It gets closer to 0 here, but it will not touch. So y is less, what is it? How do you write it? In this way. Y is less than what? Less than, okay, I erased, there's no anyway. I hope that you can see it. Less than 0. Y is such that, okay, or, okay, y is what? More than or greater than, okay, no, wait. I'll erase it because I cannot, okay, wait. I don't have space, so I went only not one way of writing the answer, so maybe this one is easier. So any real number except 0, or you can just write y is not equal to 0. Any real number except 0, or you can have negative infinity, 0, union, okay, open, 0, infinity, open interval. Okay, we need to go to the next because I give you the homework. Okay, this is skip. We will study more in our class. Okay, how about this one? How do you find the domain and the range? What is x? X minus 5. It's the same as in finding the relations. Okay, how do we do this? We do this fast because I'm done. One more time. Y equals x minus 5. Look, only look. What is the value of x here? So the domain is the set of only real numbers. Finish. Okay, so if this is real number minus 5, what is y? So that's the range. So the range is also the set of real numbers. Very easy. Okay, that's it. And we already have this for relations. The same. Okay, We skip because we don't have time. This is y equals square root of x plus 3. So what is x? Okay, x plus 3 must be greater than or equal to 0. X must be greater than or equal to negative 3. Therefore, this is the domain. Because this must not be negative. This is the same as in relations. Okay, how about for your range? The range is, if this is 0, if the answer here is 0 or more than 0 or more than 0, your y is what? Your y is what, students? Y must be greater than or equal to 0. This is the same as in finding the domain and range in the relations. And we're done with this. We're done with this to this. This is only specifically for function. Okay, this is, okay, we do this fast because I'm late. Okay, what is this? Negative square root of negative 2x plus 3. What is x? Negative 2x plus 3 must be greater than or equal to 0. Negative 2x is greater than or equal to negative 3 divided by negative 2. Negative 2x over negative 2, negative 3 over negative 2. Sorry, we will study more later. Less than 3 over 2. This is the domain and the range. Students, I will have this next time. Okay, the range is negative. Negative. The range is y is less than or equal to 0. Very good. Okay, finish. No more time. Okay, sorry. Okay, sorry, we don't have time. Okay, your homework. Okay. Next picture is coming. Okay, we will have this more next meeting. Okay, where is your homework? Coming, wait, students. Prepare your phone, scan. Okay, I have a lot of examples. Okay, no question. Okay, tick, scan. No need to copy, scan. You can answer using your phone or your laptop. Okay, this is it. Okay, don't forget to submit this. Sorry, students, no homework. I know that you are clever students. You can do everything. And you are only at home. Okay. And many of you always submit work, math work. Okay, what is that for? Okay, this is it, students. And don't worry about this. I will discuss more examples next meeting. And you can also study from Google or from YouTube on how to answer some questions that you don't know, or you can ask your classmates. I don't really have time, students. Okay, sorry if I speak so fast. You can rewatch. No, homework, please. So, Bumipat, I know that you are responsible students. Bye-bye, students. Stay safe and healthy. See you next time. Thank you for coming. No homework. Please.
Okay, is that?
No homework.